Okay, this is the subplans for Wednesday. So for first period algebra, what's first going to happen is I want you to all get out this, your notes from Learning Target 1, that was your homework from last night. So the before class. So what I want the sub to do is I want her to go around and check to see who has completed their notes. They should all have a packet of notes that they were to fill out. You're going around, you're checking in, you're seeing if they filled them out. Write their name down on a piece of paper if they did not fill it out. So you can pause this and go around and check. All right, so what you're doing is we're going to do this. So what I want you to do is I want you to share your example with your partner. I'm going to give you about maybe 3 minutes to do this. After we're done sharing, I'm going to hopefully have a couple of volunteers raise their hand, give an example, and have someone else, so like someone raises their hand and says, this is my example. And then I want a different kid to raise their hand and say why theirs isn't an example. Does that make sense? So you're going to have a little discussion. This should maybe take 5 to 10 minutes. So you can pause and do that. Okay, so you're done doing the discussion. So what you are doing for algebra is you are getting books. So remember, I don't care which partner, you can work with whoever. You're staying in the classroom though. I'm going to be checking all of this on Friday. Everything that you're doing right now, if you don't have it done, you're not getting credit. I'm giving this as a grade. So you're going to page 397 in your book. So this is all part of the focus problems, but I'm explaining this one. So right now you're doing page 397, that whole investigation. So it's going to look like this. You're going to have to tell me, you're going to have to do all of this. So tell me whether the tables are a function, why or why not, whether the statements are a function, why or why not, and whether the graphs are a function, why or why not. And then you're going to try and see if you can make a reasoning or a rule to determine whether something is a function based on the graphs. So that's going to be the first part of the focus problem. So that one was focus problem, so maybe I should add that in here. So that was page 393, I think. Hold on. Let me double check. I have it right here. Yep, so page 390, 397. So you're doing page 397, the entire investigation. Then you're doing page 394, number 11, number 13, number 14. Then you're doing page 400. You are not going to do number 4. You're going to do number 1. All you're going to do for number 1 is you're also going to tell me if it's a function or if it's not a function. So is it a function? Yes or no. Then you're going to do number 6, and then you're going to do number 7. So you're doing all this on a sheet of paper. I will be coming around on Friday to check and see if you did it. You will be getting a grade for that. We will go over the answers on Friday. That is all you're doing. Your homework is to watch Learning Target 2. Your homework is to watch Learning Target 2. All right, and that's it for you guys. And then let me get out of this. All right, let me get this set up. Okay, so for Math 8, this is going to be your warm-up. So have this on the board for them. Give them, I would say, probably 5 to 10 minutes to fill this out. So what you're doing, remember, always, sometimes, never. So a dilation creates a congruent figure. Does it always create a congruent figure? Sometimes or never, and why? So take some time right now to fill this out. After about 10 minutes, move on. So you can just pause it right now. All right, let's go over some answers. All right, so a dilation creates a congruent figure. This is a sometimes. The image gets bigger or smaller, but a dilation of 1 would give you a congruent figure, right? Dilation of 1 would be congruent. So sometimes it's congruent, but normally I would say it's a similar figure. So that's why it's a sometimes, because sometimes it can be congruent, but a lot of times it gets bigger or smaller. A transformation creates a similar figure, always. Congruence is always similar. That's what this means. Congruence is always similar. Whenever we have something that's congruent, it's automatically similar. That does not go the same thing. If we have something that's similar, it's not always congruent. So that's like down here. If we have something that's similar, congruent is always part of it, but that does not mean similar is congruent. Congruent is similar, but similar is not congruent. Congruent figures are similar. This is what we just talked about, right? Congruent figures are similar, always. Congruent figures are always similar because they always have the same angles and shape. It's the same exact everything, so they have to be similar. Similar figures are congruent. This is only sometimes. This is only if they're exactly the same. But a lot of times it's a smaller picture, right? It's a dilated picture. It's just smaller. That's not congruent. It's just similar. So that's a sometimes. All right, so that was our warm up. Now we're going to go to, let me get out of this. Before we do this though. All right, so what you're going to be doing now is there's 2 worksheets. I might have made it's either 2 worksheets or one that's front and back. You are doing that. You're handing it in, that's going as a grade. When you're done that, that's what we're doing for the first part. When you're done that, we're going to be doing an activity. So right now, you're doing those worksheets. You're doing those worksheets on congruent and similar. You may work with a partner. All right, so when we finish that, we're going to have to take some notes. So we're all done the worksheets, this is what we're doing now. So we're going to take some notes, pause this, have everyone copy it down, and then we're going to talk about it. So it should be paused right now. All right, hopefully this is a review. An acute angle, it's less than 90 degrees. It's something less than 90 degrees. A right angle is exactly 90. That's when you'll see that little square. It's exactly 90. Obtuse, it's big. It's a big angle. It's between 90 and 180. So it's bigger than 90, but it's not a straight line. A straight angle is just a line. It's exactly 180 degrees. All right, so complementary angles means they add up to 90 degrees. So these are complementary because angle 1 plus angle 2 is going to give me 90. Supplementary angles is going to give me 180. So 3 and 4, when I add them together, will give me 180. So we're going to do a little activity now, after everyone's copied this down. So from a piece of notebook paper, cut out the coolest triangle you can imagine. I don't care what kind of triangle you like. Shade each angle with your pen or pencil and then label the angles of your triangle, 1, 2, and 3 on both sides. So like I shade a little piece, shade a little piece, shade a little piece, and put a 1, 2, and 3. Then you can cut or rip off each one. So do you see how this got cut off? Rearrange the angles so they all match up. Do you see this? Yours might be a little different, but they're all going to match up like this. Does anyone not get a straight line? Everyone should get a straight line. So we're going through this. You can pause this wherever you need to. Make sure that everyone's up to here. Everyone's getting a straight line. Walk around and check. So what do we notice about a straight line? Remember, a straight line is always going to give me what? 180, which means each of these should add up to 180, which tells me that a triangle, all of the angles have to add up to 180. All of these angles add up to 180. So if we have time, we're just going to go through and find out missing angles.
Wait, I still am in here, right? Ever since